So let's talk a little bit more about the special angles, 30 degrees, 45 degrees, 60 degrees. And we're also going to do an exercise that involves what we just figured out about the sine, cosine, and tangent of these angles. But before we plunge into that exercise, I just want to make a comment about how we will often use letters of the Greek alphabet to designate angles. The Greek letter alpha, the first letter of the Greek alphabet, is drawn kind of like that. It is a lowercase a, but it's drawn in that squiggly kind of way. Beta is a Greek B, second letter. It's drawn in this way. You come up from below and do that type of thing. And that's actually where the word alphabet comes from, right? Alpha, beta. And the third letter of the Greek alphabet is called gamma. It's not a C, I think it's really a G. And it kind of looks like the alpha squiggle. Well, looks kind of like that, a little thinner and taller, but with the loop down at the bottom. And probably the most common Greek letter that we're going to use of all, more than alpha, beta, gamma, is theta, which is kind of like an elongated O with a line through it. I'll use theta a lot to denote angles in this course. Now I want to make a chart. I'm going to write theta, sine theta, cosine theta, tangent theta. And I'm going to write my three special angles in order smallest to largest. 30 degrees, 45 degrees, so 45, and 60 degrees. And I'm going to fill in the values that we just figured out in previous videos for these. Remember we did this I've written down from before for 30 and 60 degrees. And I want to make sure you realize that there's an easy way to remember at least the sine and cosines of these three angles, because you really want to memorize this. And let's just start with sine. Each one is a fraction over 2. And you can, as long as you have 30, 45, 60 degrees in this order, the values of sine just have in the numerator square root of 1, square root of 2, square root of 3. Now you might say, wait, we didn't see square root of 1. Well, square root of 1 just is 1, so that's 1/2. So there's 1/2 square root of 2 over 2, square root of 3 over 2, which are the values of sine for 30, 45, and 60 degrees. It's very easy to memorize that little trick. And then to get cosine, you just have to remember to reverse the direction. So it's square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, or just, again, 1/2. You don't have to write the square root of 1 once you see that. Now, we also calculated the tangents for each one of these. You don't have to memorize the tangents, even though most people do memorize the tangent of 45 degrees because it's so simple. And it's probably helpful to note that the tangents of 30 and 60 degrees are reciprocals of each other. But at least the sines and cosines you want to memorize. And so I'm going to just show you, I have a second yellow card here I make with just the sines and cosines of 30, 45, 60, and I just gave you a way to remember how to write them down. The tangents, we're going to have an easy way to remember the tangents, so I don't want to talk about memorizing them yet. There's another way we'll be able to remember the tangents. So, okay, so there's special angles. Now, in this video, I also want to do an exercise 4. And so we're going to apply some of what we just used. In other words, we're going to use information from this yellow card in this exercise. So if A is 30 degrees and if angle A is 30 degrees and side B is 4 in a right triangle where C is a right angle, find little a, little c, mean find the sides little a and little c. So let's try to draw a picture here. I'm going to draw a right triangle. Put the right angle here, so that's where C is. If I write 30 degrees here, then that's my A, and then my B is down here. It doesn't, A and B can be in either position, but C is always going to stand for our right angle, so little c is the hypotenuse. Little a goes down here, little b here, and we know little b is 4, right? We're given that information. So we want to find sides A and C. And now we're used to using the Pythagorean theorem. Here, if you're tempted to use the Pythagorean theorem, the problem is we're missing 2 of the 3 sides. So we can write it down, but we can't solve. We can easily find a third side when we know 2. But when we only know 1, we got to use something else. So we're going to use a trig function here. We're actually going to use SOHCAHTOA to help us. And I'm given the 30-degree angle. I have this side of 4. That's the side adjacent to 30 degrees. So I'm not going to use sine. That uses the opposite side. I'm going to use cosine. And usually there's more than one way to do this, so this is not the only way. But if I use cosine of 30 degrees, cosine of 30 degrees is the adjacent side over the hypotenuse, right? Now the adjacent side over the hypotenuse, the adjacent side is 4. That's the same as B. Over the hypotenuse is C. But that's describing the cosine ratio of 30 degrees from that right triangle. But we know from our little yellow card that the cosine of 30 degrees must always come out to be square root of 3 over 2. So that's got to be equal to square root of 3 over 2, whatever the values of B and C are. And so we get a little equation here, a little proportion equation that we can solve for C. And there are different ways you could solve. One way is to cross multiply. C times the square root of 3 is 2 times 4 is 8. And then divide both sides by square root of 3. And we get C is equal to 8 over the square root of 3, which I've been telling you is okay with me if you stop there. If you want, if you've had this drilled into you and you just can't sleep until you rationalize the denominator, go ahead and do that and you'll get 8 square root of 3 over 3 again. Same answer. I would say only one is required. At some point, I won't keep writing out 2 versions of all of these. Okay, so we got our C. We still need to find A. And, you could use the Pythagorean theorem at this point, actually, to find A, because we got B and C. But I'm going to use trig again. I'm going to now use sine of 30 degrees, which is the opposite over hypotenuse. And the opposite over hypotenuse, let's see, for 30 degrees is A over C, is A over C. We now know is that 8 over the square root of 3. Sine of 30 degrees from our yellow card, I know that always has to come out to be 1/2, so I have that memorized. So I can set up this proportion equation that we can solve for A. So I was able to use sine now because I had a value for C to plug in. And if I cross multiply here, I get 1 times 8 over the square root of 3. That's kind of nice, because then I just get that fraction by itself, equals 2a. And that 2a I can write over 1. And if you wanted, you could cross multiply again, or you could divide both sides by 2. Now, because I have a fraction on the left, I'm actually going to multiply both sides by a half. That avoids getting into fractions of fractions. And notice the 2 cancels on the right. I solve for a. And on the left, I can also cancel. 2 goes into 2 once, into 8 4 times. So I have 4 over the square root of 3 for a. And I won't write out the steps, but if you rationalize the denominator there, you'll get 4 square root of 3 over 3. So we solve for our two sides. We got c is 8 over square root of 3. A is 4 over square root of 3. We found the two missing sides of that right triangle, right? So I guess I gotta stop here if we want to see the answers.